Welcome to Math Maxtra. This is Saritha. Today our topic is perpendicular bisector and circumcenter. We'll know first what is a bisector is. See, so this is a line segment. When we say the line is bisector of this, means see, this is the midpoint of this line segment AB. Okay, this is the side line segment AB and this is the midpoint of this, means it is dividing these line segment into two equal parts. So this is the line, it is dividing this line segment into two equal parts. Okay, this is a bisector, means just simply dividing the line segment into two equal parts. Okay, this may be line segment, this may be side of a triangle, okay, whatever it may be. As this dividing the two equal parts, we call this as a bisector. Okay, coming to the perpendicular bisector. What is perpendicular bisector? Along with dividing it into two equal parts, what it also must do, it must divide the side into two equal parts, as well as it is exactly perpendicular to this line segment. Then we call this line as a perpendicular bisector. So why we call it as perpendicular bisector? Means it is dividing the line segment into two equal parts, as well as it is perpendicular to this one. That is why we call it as a perpendicular bisector. See, consider one triangle. This is one triangle. Okay. This is a triangle. So this is the midpoint of this side BC. Okay. We are drawing a perpendicular line This is the perpendicular and it is dividing this side into two equal parts. Okay, this we call it as perpendicular bisector. Perpendicular bisector. Okay. So does this perpendicular bisector always pass through the opposite vertex? Need not be. Because see, if you consider these acute angle triangles, what happened? So this perpendicular bisector passing through the opposite vertex. When you consider obtuse angle triangle, what happens? There you may have a problem that this need not pass through the opposite vertex. We'll see how it is possible. Okay. So this is a perpendicular bisector. Means sometimes this may be like this also. See, this is a triangle. Okay. So in this case, so this is the midpoint A, B, C. Okay. This is the midpoint of this BC. Now I am drawing a perpendicular bisector through this point, midpoint. What happened? It is not passing through the opposite vertex, right? That is why the perpendicular bisector need not passing through the opposite vertex. Okay. How many perpendicular bisectors are possible? See, as there are three sides of a triangle, there are three perpendicular bisectors are possible. Okay. So for each side, we can draw one perpendicular bisector. So see, okay, this is the midpoint of this AB and this is the midpoint of side AC. This is E and this is F. So for this, okay, this is the perpendicular bisector. And this is a perpendicular bisector. Okay, so what happened? So in a triangle, if you draw all the three perpendicular bisectors, what happens? The three perpendicular bisectors are concurrent at a point. So that concurrency, the point of concurrency of three perpendicular bisectors is called a circumcenter. So how? This is what a circumcenter. We can either represent it with C or S. You can represent either with C or with S. Okay. So this is what a circumcenter. Nothing but the point of concurrency of perpendicular bisectors is called circumcenter of a triangle. Okay. So this is the circumcenter of a triangle. Okay, so in the case of centroid, we have seen which is always interior of a triangle, and in the case of orthocenter, sometimes it is interior, sometimes it is exterior, sometimes it is on the triangle. So we have seen in the case of orthocenter. So come to the circumcenter. Will it always be in interior of a triangle? Need not be. So the location of a circumcenter always depend on the type of triangle we are considering. So if you consider an acute angle triangle, the circumcenter is always lies interior of a triangle. Okay, this is a acute angle triangle. Okay, this is the midpoint. This is the midpoint. Okay, so this is the circumcenter. This is an acute angle triangle and this is the circumcenter which is interior of a triangle. Okay, you consider obtuse angle triangle. So this is an obtuse angle triangle. A, B, C. Now you draw three perpendicular bisectors for this triangle. See, this is the midpoint of side AB. This is the midpoint of side BC. This is the midpoint of side AC. Okay. So we are drawing a perpendicular. Okay. And this is a perpendicular. Okay. And for this is a perpendicular for this point. Okay. So what happens? These three perpendicular bisectors are concurrent outside the triangle. So this is the circumcenter. Yes, this is the circumcenter. So which is lies outside the triangle. That is why when you consider obtuse angle triangle, the circumcenter always lies outside the triangle. Now we'll see the third case. If you consider right angle triangle, where is the location of circumcenter? Okay, this is a right angle triangle. Okay. Now you draw, this is the midpoint of side AB and this is the midpoint of side BC, C. And this is the midpoint of side AC. Okay. And this is the okay. These three are perpendicular bisectors of this right angle triangle ABC. So where they are concurrent? They are concurrent exactly midpoint of the hypotenuse. See, this is exactly the midpoint of the hypotenuse. So these three are concurrent at the midpoint of the hypotenuse. So this is the circumcenter. So for the right angle triangle, we can conclude that it is always the circumcenter lies on the exactly midpoint of a hypotenuse. Okay. So exactly the midpoint of the hypotenuse. Okay. And these are the some properties of circumcenter. Now we'll see some more. You consider one triangle. So if you draw a circle by joining all the three vertices, these are the three vertices. If you draw a circle by joining Okay. So this is a triangle ABC. If you draw a circle by joining these three vertices, so this triangle, this circle we call it as a circumcircle. Means which this triangle is inscribing the circle. Okay. So this circle we call it as a circumcircle. So for this triangle, where is the circumcenter? So somewhere here we call it as a circumcenter S. Okay. Means the circumcenter is formed by all the perpendicular bisectors of these sides. So this, let us consider this is a circumcenter of a triangle ABC. So this circumcenter is always center of this circle. So the circle formed by the joining all the three vertices of a triangle, we call it as a circumcircle. So this circumcenter of a triangle is always center of a circumcircle. Okay, which is nothing but, as this is a center which is equidistance, right? Which is equidistance from all the three vertices, isn't it? So the circumcenter, nothing but the center of this circumcircle, which is always equidistant from all the three vertices. So that equidistance we call it as a radius of the circle, right? So in, as this is a circumcircle, so this radius we call it as a circumradius. Means SA is equal to SB is equal to SC, which is always equal to circumradius. Okay. So always you have to remember that in all the centers, whether you consider centroid or orthocenter, circumcenter, and all the centers you consider, the circumcenter is always equidistant from all the three vertices. Okay. So that distance we call it as a circumradius. And in the questions, we have to calculate the circumradius. So if you consider a right angle triangle, see, if you consider a right angle triangle, so this is a right angle triangle. Just now we have seen for the right angle triangle, the midpoint of the hypotenuse is always the circumcenter of this triangle, right? So this we are calling it as a circumcenter. Okay. So what is the circumradius of this? Which is nothing but the distance from the center to the vertex, right? So this is nothing but a circumradius, isn't it? So in the case of right angle triangle, so always the circumradius is nothing but hypotenuse, whatever may be the hypotenuse, by 2, isn't it? Exactly midpoint of the hypotenuse we have circumcenter. So this distance from the circumcenter to the vertex we call it as a circumradius. So what is the circumradius? Is nothing but exactly half of the hypotenuse. We always represent circumradius with capital R only. Okay. And for regular triangle, how can we calculate a circumradius? See, we can calculate circumradius by ABC by 4 delta. Okay. By this formula, we can calculate circumradius for any triangle. Okay. See, these ABC are nothing but sides of a triangle, and this delta is nothing but area of the triangle. So, you may consider sometimes one type of triangle, you may consider sometimes other type of triangle. So, that case, the area of the triangle may be different for different triangles, right? So, for that, the area of the triangle we are represented by a delta, and these small a, small b, small c are nothing but sides of a triangle. So for any type of triangle, we can calculate circumradius by this formula. Capital R is equal to ABC by 4 delta. So you consider an equilateral triangle. What happens in the type of equilateral triangle? area of the equilateral triangle is how much? Root 3 by 4 a square, right? This is the area of equilateral triangle. And all the sides are equal, right? A is equal to B is equal to C. All the sides are equal. You substitute these two in this. What happens? A into A divided by 4 into root 3 by 4 A square. Okay? This one. This one. So what happens? A by root 3. So the circumradius of an equilateral triangle is A by root 3. This is the circumradius for equilateral triangle. Okay. So this is the circumradius for equilateral triangle, and this is the circumradius for right angle triangle, and this is the circumradius for in general any type of triangle. Okay, that can be scalene triangle. If in the case of scalene triangle, what happen? All the three sides are different, and what is the area? Area is nothing but under root of s into s minus a into s minus b into s minus c. So from that you can find the area of your triangle. Then you can substitute all the three sides of a triangle. Then you can calculate circumradius of a triangle. Okay, so see, this is the circumcenter of a triangle. So we have one relation, that is this is the angle. If we consider this is the angle theta. Okay, this total angle is theta. So the angle subtended by this side at the circumcenter is the circumcenter. So the angle subtended by this side, opposite side on the at the circumcenter. So this angle is always twice of this angle. If this is theta and this is 2 theta. So that is the relation between this angle and this angle. So which is nothing but angle BSC, which is equal to exactly 2 times of angle A. This relation is important in the case of circumcenter. Okay. These are some properties which are related to circumcenter. Thank you.